So let's talk about fair games. We got expectation out of the way yesterday, kinda. And what we did was we used NP to figure out what the expected value of a system would be. And basically, an expected value of a system just means the average result of the system. That's all that means. And we found out that the average result of rolling a single die is actually 3.5 outside the system. That happens, whatever. How did we do this stuff? Well, you take all the events, you multiply the event by the probability the event occurs, and add all those up. So you add up your XIPIs, and that is the mean expected value of that system. Enter fair games. In gambling, we say that the expected gain, not the expected value, the expected gain of a player from each game is the expected return or payout. That does not guarantee it's positive, though. Yes, clearly in normal language we say, I gained money, right? But you could have a negative expected gain, which would be a negative expected return, which is what the casinos are counting on. So anyway, the expected gain of the player for each game is the expected return or payout from the game minus the amount it cost them to play. So let's just say that the expected gain of playing is $3. The average player is going to win $3 per game. So what does the casino do? They charge you $4 to play. That way, the average person loses. So over time, over enough trials of this experiment, casino makes money. Will there be some people that make more than they lose? Yes. But because the average player loses, overall, the casino makes money. They don't care if Joseph wins as long as everybody else loses. And that's why they can offer such huge jackpots. It doesn't matter. Just think about it like this. Every time you see a casino jackpot that's outrageously big, think of how many people's mortgages didn't get paid, how many people's groceries didn't get purchased in order for the jackpot to be worth that much. Just saying. Okay. So what makes a fair game? A fair game has an expected gain of 0, meaning the average player will win as much as it costs to play. No gambling games work this way. Otherwise, the casinos wouldn't make money over time. So suppose, would you tell me before I stand up that I'm not sharing? This guy. One of these days, I will learn how to do my job. I swear it. Not only is he not seeing the board, they're also not seeing me at the board. There we go. Okay. So suppose capital X represents the gain of a player from each game. The game is only fair if E of X, meaning the expected value, is 0. That's what makes it fair. In a game of chance, a player spins a square spinner labeled with the numbers 1, 2, 3, and 4. That's it. You're just going to spin a spinner. The player wins the amount of money shown to the right. So you spin a 1, you win $1. You spin a 2, you win $2. Spin a 3, $5. Spin a 4, $8. So big money's on the 3 and the 4, right? So depending on which number comes up, we need to determine these 3 things. So first, let's determine the expected return for one spin. Expected return for one spin. Well, what we need to do is we need to figure out what our XIPIs are. That's the event times its probability. I guess it would be nice to know what the probabilities are, wouldn't it? So maybe we make a new table. Maybe we make a new table that has the probabilities in it, and then the value, and then the winnings for that value. What do you think? Because I need to know what each spin looks like payout-wise. Do you have to make a new table? No. We're assuming it's a fair spinner. What a weird thing to talk about, talking about fair games and fair spinners. We're assuming that each of the 4 spins is equally likely. So what are all of their probabilities? 1/4. So it's not that I'm going to do 1 times 1/4, 2 times 1/4, 3 times 1/4. No. What I'm going to be doing is the payout for that spin. So I tell you what I'm going to do. I want to add my probabilities. And I want you to understand that these are your outcomes. The money you make per spin are the outcomes. So our outcomes are $1, $2, $5, $8. And the probability of each one of these is the same. We're assuming our spinner is divided equally. So 1/4, 1/4, 1/4, 1/4. I'm kind of like, I'm adding to my table here. So let's see. Did I have to do it this way? No, but I think it makes it easier to see. And then the xi, pi, which is just the product of those two things, would be down here. Pi means the probability of each x term. So xi means x1, x2, x3, x4, x5. And actually, there's only 4. So we have x1 times p1, x2 times p2. That means probability that x2 happened. x3, p3. That means the probability x3 happened. Okay. And we just multiply. 1 times 1/4, 1/4. 2 times 1/4, 2/4. Don't reduce your fractions. 5 times 1/4, 5/4. And lastly, 8 times 1/4, 8/4. Don't reduce your fractions. A. E of x did we do x? Yeah. So E of x is sigma xi pi. That just means add up those things you just found. 1/4 plus 2/4 plus 5/4 plus 8/4. That is 16/4. Did I do my math right? Yes. Which is 4. Oh, okay. So look at that. The average player would win $4. Is it possible for you to play this once and win $4? No. So what does this tell you? It tells you that if you yourself played this game hundreds of times, it would have averaged out to $4 per spin. That's how much you would have gotten from the spinner.
Why would you not be able to play it once?
Because the only possibilities are 1, 2, 5, and 8. It's just not one of the possibles.
Oh, okay.
It's like saying the average die roll is 3.5. It's not even possible, but over time, that's what it ends up being. So this is your expected return. It says the expected gain of the determine the expected gain of the player if it costs $5 to play each game. Oh. I labeled my variable wrong. I should have used x. I'm sorry. Because I just told you up here, this is my apologies. I'm going to change it to a y. Because E of x is the expected gain. This was the expected return. My apologies. That's on me. I'm waiting for my panel to catch up with me. There. Let's change these to y's. Because E of x specifically is the expected gain, I was originally finding the expected return. Sorry. Yippee! Will someone please let whoever that is in, please?
Also, the first one is still just PI.
Yeah, it's still PI.
So you switch both of them to
They're y's instead of x's.
yeah, the 1/4 that they call it the row with just 1/4 still just PI without y.
P stands for probability.
Yeah, before you just had a PI and then the one below it was y.
Oh, I see what you're saying. I put a y here.
Yeah.
Okay, I'll be all right. Okay, it's gonna restart the video now. There we go. Anyway. So y is the outcome, pi is the probability the outcome occurs, and yippee is how much you would get if you multiplied the probability and the outcome. So our expected return is $4 per game. So the average player wins $4 per game. B, we have to find the expected gain of the player if it costs $5 to play. Well, The expected gain, and that's why I said I used the wrong variable. E of x is expected gain, is 5 minus E of y, or E of y minus 5, excuse me. How much you earn per hand minus what it costs you to play. Uh-oh. The average spin results in a dollar loss. The average spin results in a dollar lost. Will everybody lose a dollar? No. Some people are going to win money. But the average spin cost you $1 more to play than you won. So part C says determine whether or not you would recommend playing this game. And this is like legitimately an IB question. If it says determine whether or not you would play, you go, well, C. And you go, since E of x is less than 0, game is unfair. Or let's just say not fair. Game is not fair. Do not play. I'm sorry? So a good question would be, well, let's just say the, I don't know, the value of the 2 goes up. It's no longer worth $2, it's worth more. I could say, how much would that 2 need to be worth in order for this game to be worth playing? You could do things like that. But we would have to recalculate E of y, and it would have an unknown in it, and we would have to solve.
Can you figure out this math if you just went to a casino?
Can I figure it out, or can anybody?
Can like you just like?
I mean, the odds, and these aren't odds, these are probabilities, but odds are never a secret. They have to be made public. They tell you what the odds of winning and losing are. Yes? So the 4 is, let's just say you didn't have to pay to play this game. I'm just saying, hey, you want to play a game? All you can do is win. The average player wins $4. That's what that means. Now, clearly, you can't win $4 with one spin, but if you spun it 100 times, math says you should have ended up with right around $400. So the average spin would have got you $4. Here's the thing. You paid $5 to play every time you spun it. So on average, you lost $1 per spin. That's what's going on. So so E of y, the 4, is the expected return. That means what do I get just for playing? The expected gain is the difference between returns and cost to play. So a negative expected value, expected gain, is good for the casino. That means the average player will lose. That's what they need.
Can you explain what E is?
E just stands for expected. It's mu. It's the average. Yeah, E of x, E of y. It means, so E we just use for expectation. The expectation for variable y, where y was just, so you can say like we could name, we could say let y be payout per spin. If that wasn't clear enough, what was going on in the table. So the letter y is telling you what the payouts are. So the average payout's $4. E just says expectation. So E means what is the expectation on the payouts? And X, for X would be expected gain. So X would be gains per spin, if you want to do it like that. So let X be gains per spin. And just because I use the word gains does not guarantee that it's above 0. So Y would be the payouts. So the expectation of all the payouts is 4. But the expectation of the gains is actually negative because each spin costs you more to play than what the average spin returns.
So why did you do EY minus 5?
Because this is how much, so here's what it is. I won this much. It cost me this much per spin.
Okay.
So it's like, just as I was telling her, I said, okay, let's just say the average spin gets you $4. So you spin 100 times. You have $400. Woohoo! Except you paid $5 to spin it. So you've actually paid $500, and overall so if you pay $500, you now have a negative value, negative 500, right? You won 400 of it back. You still have a negative value, negative 100, and that's what the negative 1 is representing there. Okay, so now let's do the 2 extra practice questions that I've given you. All the talking really tells me that the expected value of the next test is not going to be very high. You can see this is labeled number 5 because I pulled it right from the textbook. It's numbers 5 and 6 from the homework that I did not assign. In a carnival game, a player randomly selects a ticket from a box of tickets numbered 1 to 20. Oh boy, there's 20 different tickets. If the selected number is a multiple of 3, the player wins 5 tokens. If the selected number is a multiple of 10, the player wins 10 tokens. Oh, cool. So what happens if I don't get one of those 2 things? How many tokens do I get? You get 0 tokens. So let's use y. Let's use the variable y for the outcomes. Ooh, that's red. I don't want to use red. Let's use the variable y for outcomes. Our outcomes are 0 money, 5 money, and 10 money. These are your possible outcomes. These are the probabilities those outcomes occur. All right. I think it'd be easier if we count up the winnings first. How many numbers between 1 and 20 are multiples of 10? 2. I said 10. 2. So there are 2 out of 20 here. Do not reduce. How many numbers between 1 and 20 are multiples of 3? 6. So we have a 6 out of 20 of that occurring. Do not reduce your fractions. I meant to write 20. I meant to write 20. Because 2 out of 20 is 1/10, and I was trying to say do not reduce. And in my mind, I've reduced. What?
You said 3 out of 20, and then you put in $5
What are you talking about? A multiple of 3. Gavin, listen to me, not TikTok, please. Because you could spin a 3, 6, 9, 12, 15, or 18. That's how much money that gets you.
Oh, okay. I was confused.
These money values are how much the result is worth. Okay?
See, I was the only one who got tripped up.
Yeah, because the person sitting next to you that's probably talking to you also didn't hear me. Anyway, if I've already used 2 and 6, how many are left over? Thank you, one person. Holy crap.
Wow.
This next test is going to be so bad.
Not as bad as the one I'm about to take.
When?
Period. I told you I was coming in period. Because I want to go over my test with you tomorrow.
YIPI, the yippee. This is multiplying straight down. 0. 30 out of 20. 20 out of 20. I'm doing a lot more. I'm just doing a lot of everything before I've even read the questions. Since I already know this, I know that the expected return, or the sum of the yippies, is 50 over 20, or 2.5. Okay, cool. I've got a lot of information. Let's just go ahead and see what the questions even ask, because I don't even remember. Let's see. AI says calculate the probability of a player winning 5 tokens. Oh. Well, we already know that. It's in the table. It's 6 out of 20. So AI is 6 over 20. And the 10 tokens, it's 2 out of 20. There is no reason to reduce your fractions. Oh, these people said x is going to be the expected value of x. I don't like that. Let's change it to a y, because I used y because I want e of x to be the expected gains. I want e of x to be the expected gains like the notes say. I don't know why the book would change their own variables like that. Okay, part B says find the expected value, which is of y, which would be the expected returns. Oh, we just did that. So that was actually part B. The expected returns is 2.5 tokens. So if you played hundreds and hundreds and hundreds of times, you would have an average of 2.5 returned to you for every play. Let's see what the next part says. If it costs 3 tokens to play the game, would you recommend playing the game many times? If it costs you 3 to play, and the average return is 2.5, would you play it? No. C. Because expected return is less than the cost to play, you should not play. Will some people be statistically lucky? Yeah. But on average, no. And that's all that matters is averages. As long as thousands of people play, who cares? Anybody ever been on a cruise?
Yep.
The casinos and the alcohol and the what are those excursions? The last cruise that I went on with my wife, this is long before we had, no, excuse me, the last cruise I went on with just my wife, long before we had kids. We just went just for our anniversary, just to go on a cruise. No excursions, no alcohol, no gambling, just to go out. Because you can get off the boat. You can get off the boat and walk around and see neat stuff. You don't have to pay to do that stuff. So we just paid for the cruise, which means basically food and beverage for a week and lodging, everything was already covered. You just and I think the tip was like rolled into the cost. So it was one of those ones where you didn't have to leave money for a tip. It was just rolled into the cost of your trip already. And I asked the cruise director, because every day we went and did the free stuff, and a lot of it was done by the cruise director. And I was like, so just curiosity, people like my wife and I, no gambling, no alcohol, no excursions. Before I could even finish my statement, he says, we lost money on you. He was like, but it doesn't matter because so many people are going to drink and gamble that we will make money. This is right out of the people's mouth. He said, oh yeah, we lost money on you.
What do you mean they lost money on you?
Because we didn't pay for all the stupid things. We didn't pay for alcohol, and we didn't pay to gamble, and we didn't go on any excursions. So even though we gave them so much money for the room, based on the amount of food that we consumed and beverages that we consumed,
You gained money.
they lost money on us.
Yeah.
But they gained so much money on everybody else that is boozing and is gambling that it makes up for us, because on average, it doesn't matter. Now, if they were just going to take me and my wife out and that's it, they wouldn't. But the average person spends so much more than they paid to have you, no big deal. It's all. Actually, drink packages are a ripoff. Okay, so talking cruises. When I go on cruises now, I go with my in-laws, and that's because they want to go on cruises, so they pay for it, which is really nice. And my father-in-law, he thinks he's going to drink a lot, so he always pays for a drinking package because it just burns him up that one drink costs so much money. And I did the math the last time we went out because he paid for me to have a drink package. And I told him, I was like, do you know how much I have to drink in order for it to pay for this drink package? I was like, drinking has to be my job this week. He was like, I'm having breakfast. Why don't you have 3 mimosas? I'm like, because I don't want alcohol. I just woke up. You know, I mean, it was like that. Like, but it was the only way. He'd be like, so we'd be at lunch, and he would be like, go to the bar to get a beer. And he'd be like, but tell him you want 2. And I was like, but I don't. It was like a job. I'm like, I just want like a ginger ale. You know, I'm not trying to. Yeah, no, the drink packages are a total ripoff.
Well, you get the regular one that's not alcoholic, I don't think.
Oh, that for sodas and stuff?
Yeah.
Do you know how much money soda costs?
Soda costs?
It's basically free. It costs them nothing.
It's $14.99, but if you pay for it separately, it's probably like $3 a drink.
Or you could just drink the free stuff. water and tea and stuff like that. Juice at breakfast. I mean, like, it's free. Coffee. This guy. Okay. A person selects a disc from a bag containing 10 black discs, 4 blue discs, 1 gold disc. There are 15 discs. They win $1 for a black disc. Okay, so again, let's let y be the expected returns. So what are the options for the expected return? $1 is an option, $5 is an option, and $20 is an option. But the probabilities of those things occur, let's see. A black disc, 10 of them are black. 10 out of 15, I'm not going to reduce. Let's see. 4 of them are blue, and a single one of them is gold. So if you were trying to figure out the expected return of this, is this a game? I don't know. Then you would need to figure out what your yippies are. So you get 10 out of 15, 20 out of 15, and 20 out of 15. So what is the expected return? The expected return is 50 over 15, which is 3.3 repeating. The expected return is 3.3 repeating. Sorry, I used a sigma instead of an e. It just happened. To make the game fair, the prize money for selecting the gold disc is increased. But we don't know to what. It says find the new prize money for selecting the gold disc. So what would need to be true in order for the game to be considered fair? We need the expected gain to be 0. We need e of x to be equal to 0 for it to be fair. But how is e of x calculated? E of x is calculated by taking your returns and subtracting the cost. Where is it? Oh, I just can't see it anymore. I was looking for it. So right now the average player loses 67-ish cents per play. We know that the gold ball, we know its value went up. Let's figure out how much in order to make this game fair. Here's what we need. We need the expected return to be 4. That's what we need. That's the only way the game is fair. I'm sorry? Yeah, negative. I said costs, and I forgot to write the minus sign. We need the expected return to be equal to 4. Then that game would be fair. So then the yippee now, since we don't know the value of spinning the or picking the gold one out, now the yippee would be, actually I'll make a new table to make it easier. Come on, active panel. Okay. The probabilities have not changed. All that's changed is the y's. Shh. 1, 5, unknown. We don't know how much that one is worth. The probabilities have not changed, though. They're still 10, 4, and 1 out of 15. These are the PIs. Just using up a buttload of vertical space here because I can. What is going on right now? It doesn't like me. Okay. The yippies, 10 out of 15, 20 out of 15, unknown out of 15. So when we add those up, we get 30 plus an unknown divided by 15 minus, equals 4. This is what must be true. Because we needed the E of Y, the expected return, to be equal to 4 in order for the game to be fair. So I added the yippies. We'll multiply both sides by 15. X must have been $30. There. Painful.